In this episode, we are taking the idea of a cybersecurity lab and making it feel practical, approachable, and worth your time, especially if you are still new enough to wonder whether building one is something only advanced people do. A lot of learners hear other people mention home labs as though everyone should automatically know what that means, and that can make the whole topic sound more technical and expensive than it really needs to be. The truth is that a lab is simply a safe place to observe, test, and connect ideas that would otherwise remain abstract. For someone studying for the CompTIA Cybersecurity Analyst, CySA+, that matters because so much of the certification lives in the space between concepts and evidence. A good lab does not exist to impress anyone. It exists to give your learning a place to become visible, so you can stop imagining what logs, alerts, endpoints, and network behavior might look like, and begin seeing simplified versions of them for yourself. One of the most useful mindset shifts is to stop thinking of a lab as a miniature corporate network that must be perfect before it can teach you anything. Beginners often delay building a lab because they picture racks of hardware, enterprise licenses, and a maze of tools they do not yet understand. That expectation is not only discouraging, but also unnecessary. A lab is a learning environment, not a museum exhibit. Its value comes from supporting curiosity and repetition, not from how impressive it looks in a photograph. If your lab lets you examine an operating system, OS, observe network connections, create and review logs, compare normal behavior with suspicious behavior, and safely reset the environment when you make mistakes, then it is already doing important work. The simpler your lab is in the beginning, the easier it usually is to understand what is happening inside it. That clarity matters more than scale, because confusion does not become education just because it takes place across more machines. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Before building anything, it helps to decide what kind of questions you want your lab to answer. That may sound obvious, but many learners skip that step and end up building a collection of disconnected pieces rather than a useful training space. If you are studying for CySA+, your lab should help you understand how systems behave, how logs are generated, how vulnerabilities appear, how network communication leaves traces, and how an analyst might notice that something has changed. Those goals naturally point you toward an environment that includes at least one system you can treat as a user machine, another system you can use for observation or support, and some way to generate or collect evidence from what happens. Once you define the learning purpose, decisions get easier. You no longer ask whether your lab needs everything. You ask whether your lab helps you see the categories of activity that matter for analyst thinking, which is a much more useful standard. Hardware expectations also become much less intimidating when you approach them with a learner's mindset. You do not need top-tier equipment to begin learning. What you need is a machine that can reasonably support several isolated environments at once without becoming so unstable that the experience turns into constant frustration. That usually means paying attention to memory, storage, and processor capacity more than flashy extras. Cybersecurity labs tend to become more practical when they can run multiple workloads without slowing to a crawl, because that lets you compare activity across systems instead of only reading about it. At the same time, beginners should resist the urge to overbuild too early. A lab that you can actually use this month is worth far more than a grand design that stays trapped in planning. The right starting hardware is not the most powerful hardware on the market. It is the hardware that supports stable experimentation, fits your budget, and allows you to grow the environment gradually instead of trying to buy your way into expertise all at once. Virtualization is one of the foundations that makes home labs practical for modern learners. A virtual machine, VM, is simply a software-based computer running inside a host system, and that idea changes everything because it allows one physical device to support several separate environments at the same time. For cybersecurity learning, that matters because you can create multiple systems with different purposes without filling your room with separate hardware. One VM might act as a normal user workstation. Another might serve as a monitoring or logging system. Another might become a deliberately simple target for controlled exercises. The biggest educational advantage of virtualization is flexibility. You can create, modify, reset, and compare environments in a way that would be far more cumbersome with only physical machines. It also teaches an important mental habit for analysts, which is understanding that systems can be separate in function and behavior even when they share underlying infrastructure. That separation helps you create small, understandable scenarios where evidence has context instead of appearing out of nowhere. As you think about what systems to include, keep your focus on roles rather than brand names. A beginner lab becomes much more useful when each system has a purpose you understand. One machine might be your normal endpoint where user behavior occurs, files are opened, accounts are used, and processes start and stop. Another might be a logging or analysis system where events are collected and reviewed. Another might be a server-like environment offering a service, so that traffic has somewhere meaningful to go. You may also want a system that exists mainly for testing suspicious behavior in a controlled way, such as generating unusual logins, failed access attempts, or network patterns you can later study. The lesson here is that lab design should mirror analyst questions. Analysts care about relationships between systems, identities, services, and evidence. A lab becomes educational when those relationships are visible enough that you can observe one change and then follow its effects elsewhere in the environment. Networking inside the lab deserves attention because it is where many cybersecurity concepts start feeling real. When a beginner first studies security, systems can seem static, almost like isolated boxes described in a textbook. A lab shows that systems are constantly communicating, and that those communications create the traces analysts later examine. You do not need to become a network engineer before your lab becomes useful, but you do need a simple mental model of how traffic is moving. Which systems can talk to each other? Which ones should not? What kinds of activity stay internal? And what kinds of activity reach outward? Even basic separation can teach a lot. If one part of your environment behaves like a small internal segment and another behaves more like an exposed or shared space, you begin to understand why segmentation matters and why analysts care about unexpected movement between systems. Good lab networking is not about complexity for its own sake. It is about making communication patterns visible enough that they can be noticed, questioned, and learned from. Safety is one of the most important design principles for a cybersecurity lab, especially for someone still building confidence. A lab should be a place where you can test ideas without accidentally creating problems for your normal devices, your household network, or anyone else on the internet. That means isolation matters. Your experiments should stay inside boundaries that you understand and control. If you are generating suspicious behavior, scanning systems, creating bad login attempts, or working with intentionally vulnerable environments, those activities belong inside the lab and not on systems you actually depend on for work, family, or daily life. Safety is not a boring side concern. It is part of learning professional discipline. Real analysts are careful about scope, impact, and unintended consequences, and a good lab teaches those habits early. Building safely also makes you more willing to experiment, because you know you can make mistakes, reset systems, and try again without creating damage you never intended. Another smart principle is to build the lab in layers instead of trying to finish everything in one burst. A first layer might simply be one host machine and 2 VMS, enough to begin observing basic system behavior and simple communication. A second layer might add logging, so that actions on one system become reviewable evidence on another. A third layer might introduce a controlled service, a more realistic user workflow, or a system that helps you observe suspicious behavior with greater clarity. Building in layers helps because each stage teaches you something before the environment becomes more complex. You get the reward of early progress, and you avoid the common beginner problem of creating a large environment you do not yet know how to interpret. Layering also mirrors how security understanding usually grows. People do not become good analysts by mastering the entire environment at once. They become good analysts by understanding one relationship, then another, and then seeing how those relationships fit together. Logging and visibility should become central parts of the lab as soon as you reasonably can, because a cybersecurity environment without evidence is educationally limited. A learner may build several machines and still miss the heart of analyst work if those systems generate activity that is never captured or reviewed. The point is not to collect every possible event. The point is to create enough visibility that actions leave traces you can study later. When a user signs in, a process runs, a service starts, or a system reaches out across the network, you want some of that behavior to become visible beyond the moment it happens. This is what starts turning the lab into an analyst environment rather than just a collection of operating systems. Once you can review what happened after the fact, you begin learning some of the most important habits in CySA plus thinking. You compare normal behavior to unusual behavior, ask what sequence of events occurred, and begin to see why evidence quality matters so much in detection and response work. A security information and event management (SIEM) platform or any simpler logging approach can support that visibility, but the beginner lesson is bigger than any one category of tool. You are trying to understand what kinds of records help make security decisions possible. If your lab lets you notice login patterns, process launches, service changes, outbound connections, or failed access attempts, then it is already moving you in the right direction. The same general idea applies to endpoint and network visibility. An endpoint detection and response (EDR) concept becomes easier to understand once you can see why analysts care about what a device is doing locally. Network monitoring becomes easier to understand once you can see why communication patterns matter. The tool categories become meaningful because the environment gives them a purpose. That is one of the strongest reasons to build a lab. It allows security technologies to stop being merely names in a study guide and start becoming windows into system behavior that you can actually observe. It is also worth creating a small amount of intentional normal activity before trying to generate suspicious activity. Beginners sometimes rush straight into attack simulations or unusual behavior without first establishing any baseline, which makes it harder to understand what actually changed. Normal activity gives your lab contrast. A user signs in at expected times, browses a few pages, accesses a file share, opens an application, or connects to a common service. Once you have seen what ordinary behavior looks like, even in a simplified environment, the unusual begins to stand out more clearly. That might be a burst of failed logins, a process starting from an odd location, a sudden connection to an unfamiliar destination, or a service behaving in a way you did not intend. This contrast is educational gold for a future analyst. So much of security work depends on recognizing deviations from what should ordinarily happen, and your lab becomes a training ground for that kind of pattern awareness. Documentation is another part of lab building that students often underestimate, but it can transform the learning experience. If you make changes without recording what you did, the lab quickly becomes harder to understand, harder to troubleshoot, and harder to learn from. Clear notes help you remember which systems exist, what role each one plays, what changes you introduced, and what behavior you expected to observe. Documentation also sharpens your thinking because it forces you to explain the environment in plain language. If you cannot clearly describe what a machine is supposed to do or why a certain network path exists, then the design may not yet be as clear as you thought. This matters for CySA+ because analysts do not only detect and observe. They also communicate, track changes, and preserve enough clarity that others can make sense of the environment and the events inside it. A well-documented lab quietly teaches those habits every time you revise it. One of the best ways to know whether your lab is becoming useful is to ask whether it helps you answer analyst-style questions more naturally over time. Can you explain which systems are present and why? Can you identify what normal activity looks like? Can you tell where logs come from and what they reveal? Can you generate a simple event and then follow its traces? Can you describe why segmentation, visibility, or isolation matters using your own environment as an example? When the answer to those questions starts becoming yes, the lab is succeeding. It is helping you connect theory to evidence and evidence to judgment. That is much more valuable than having a huge lab that you barely understand. The real purpose of building your own cybersecurity environment is not to imitate a giant enterprise all at once. It is to build a small but growing world where core security ideas become visible enough that you can observe them, question them, and gradually think more like the kind of analyst CySA+ is designed to develop. By the end of this discussion, the main idea to carry forward is that a good cybersecurity lab is not defined by cost, complexity, or how closely it resembles someone else's setup. It is defined by whether it helps you learn the right things in a safe and repeatable way. Your lab should make systems, communication, logging, identity, and suspicious behavior easier to understand, not harder. It should grow in layers, stay within boundaries you control, and give you repeated chances to compare normal activity with unusual activity. Most of all, it should serve your learning rather than your ego. When you build a lab with that mindset, the environment becomes more than a technical project. It becomes a private training ground where analyst thinking starts to become real, and that makes it one of the most useful investments a CySA plus learner can make.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.